So as we use our data visualization tools to visualize databases, to visualize data cubes, these data cubes are data hypercubes. They're going to be high-dimensional databases with lots of dimensions. Our challenge is going to be getting that information presented on a two-dimensional screen. And as we've seen before, we can use worlds within worlds. In this case, we're visualizing a four-dimensional hypercube of our World Bank indicator data. We're looking at life expectancy versus infant mortality, but we're also looking at that over different regions and also over different years. And so we have this worlds within worlds. We're looking at a four-dimensional hypercube where we're plotting a table of region versus year, and each element in that table is itself a two-dimensional plot of life expectancy versus infant mortality. And so this gives us a four-dimensional view, but we can expand from just that worlds within worlds idea to the general idea of the organization of these axes. And each of these axes is representing different dimensions of our data, and the relationship of the dimensions of our data is organized quite well in OLAP databases as the relationship between keys. So these database visualization systems have special tools designed to help organize axes, especially since those axes are often used to display multiple dimensions or represent different aggregations or projections of multiple dimensions in order to reduce the dimensionality of a large hypercube. These arose from a paper on Polaris. Polaris is an early prototype system that was a precursor to Tableau. So one of the things you can do with axes is concatenate them. You can take two dimensions and place one dimension after the other in order to display that on a single axis. And it provides basically multiple views of the data. For example, here's our sales data plotted by quarter. And so you can see that the sales were low in the first two quarters, and then they increased in the second two quarters. And so we can concatenate the time axis, the time dimension, with the product dimension into a single axis that has time followed by product. And so we're getting two views of the same data, but in the first half of the axis we're seeing the data plotted over time separated by quarter, and in the second half of the axis we're seeing the same data plotted but separated by product. And so we can see that this general trend of sales over time is being followed by the three different products, but it's more accentuated with one of the products than it is perhaps with the other two. And so that makes sense to concatenate a time axis with a product axis in this case. It may not make sense to concatenate a quarter axis with a month axis because they're both time dimensions. And so you'd be seeing the same plot here over the demarcations of quarter, and then the same plot over the demarcations of a month, and you'd be using half of the space to build this up. And so it doesn't make as much sense in that case. We can also take two dimensions and create an axis from the product of those two dimensions. For example, if we have the data over time over 4 quarters, and we have the data over products, instead of showing them side by side, we might show the data for the coffee, espresso, and tea, the product values for quarter 1, quarter 2, quarter 3, quarter 4. And so this product basically gives you every combination of coffee and quarter, so that you can see how your data is performing over time and product simultaneously, with a single axis here representing these two dimensions by looking at all the combinations. Similarly, we could look at quarter times month. This doesn't make much sense either, because we'd be looking at the first quarter, which should represent just the first 3 months, and yet I'm plotting all 12 months here. And so just doing a simple product of two time axes doesn't really help, because I'd only have data for the first quarter showing up in the first 3 months, and then the other 9 months would basically be zero valued, because there wouldn't be data for these months that was also in the first quarter. What makes sense for this case is to do something called nesting. And nesting is a way of limiting the combinations to the combinations that are available in the database. And so in quarter one, maybe we didn't have any sales of tea. And in quarter three, maybe we didn't have any sales of espresso. And so by doing this nesting operation, it's basically similar to a product, except we're not looking at every possible combination. We're only showing on the axes the combinations that actually exist in the database. And so now if we have the month nested inside quarter, if you have quarter as the major axis and then the minor axis is the month, we're not seeing January, February, March, April, May, June all in quarter one. We're only seeing the months in quarter one where we have actual data values in the database. And since January, February, March are the 3 months in quarter one, we'll have data values there, but we wouldn't for April, May, and June. We won't have any data values for April, May, and June in quarter one because April, May, and June are in quarter two. And so that nicely nests this higher resolution time axis into this coarser resolution time axis into a single axis. So Tableau has some functionality that helps organize axes nicely. If we take our life expectancy data and display that, we get an average over all time over all the countries. And so we can start to disaggregate this data by country, and what we will get is an alphabetized list of all the countries. If we want to organize this better, we can organize it by the continents. And now we get continents on the top, and then all the countries alphabetized by the continents, and then we can insert a subregion in here that further refines the data by subregion. So you get this nice organization that Tableau can automatically discover based on the data that's in there, because the data is in there by country, by region, and by subregion, and it can detect how that data should be organized hierarchically in the axis by each one of these sections. So it's by region, then subregion, then country and region. And so we've got Africa and Eastern Africa, and then we have all the countries alphabetically in Eastern Africa. We can further subdivide this axis. For example, if we want to look at, if we want to disaggregate by the year, each one of these bars represents the average over a year. If we want to drill down into how the performance is over each year, I can add for each country the performance over each year. And now for each country, I've got the performance per year, and this might look better actually as a line graph, so that we can see how each country is improving its performance in life expectancy over the 10 years that we've recorded it here, the 11 years I guess that we've recorded it here. You can also move the year in between, and so now we're seeing the performance of on a per region basis. This is how each of the countries in a given region are performing over a year. And then finally you can move year all the way out, and now we're seeing for each year the different breakdown in the countries. And so you can set up these hierarchical axes and get worlds within worlds. You can even put it on the vertical axis, and you can get a higher dimensional view of your data by basically implementing a worlds within worlds visualization, where you have a table of plots, and each cell of a two-dimensional data is itself a two-dimensional plot or two-dimensional table, or in this case a two-dimensional bar chart. So we can see how information visualization systems specifically designed for visualizing databases, specifically OLAP DataCube style databases, can provide a database user with visualization tools to gain insight into the data.